Question 703, case largest element in a string. Design a class to find the case largest element in a string. Note that the case largest element in the sorted order, not the case distinct element. So what we are going to do, we have a class, it has two functions, the init function and add function. In the init function, we are going to define the list, and in the add function we are going to add elements to the list. So based on what the question is asking us, let's go through an example so we can better understand the question. Let's say two elements are given to us. One is k, which is an integer, and nums, which is a list of integers. So k is given to us and nums, which is a list, is given to us. K, for example 1, is equal to 3 and nums is equal to 4582. So it says after defining the class, the output is going to be null. So when we define the class, we are not going to return anything. After that, we are going to add like an integer every single time, and when we add the integer, we are going to return the k's largest element. Let's see how it happens. So we are going to add let's say 3, and I'm going to add it to this list, right? So after adding 3 here, so it is going to be added to the list, right? So how am I going to return the k's largest element? The easiest way to do that is I sort this array and return the third largest element for this example. So what I'm going to do, I'm going to say 2, 3, 4, 5, 8, and I'm going to return the third largest element, which is going to be 4. Let's add another number. I will add now I will add 5. And after adding 5, because it's sorted here, so what will happen is I'm going to add 5 here, and then I'm going to sort it again, which is going to be what? It's going to be 5 will be added here. And then I will going to get the third largest element, which is going to be 5, and so on, right? But as you see that every single time that we are going to add an element, we have to sort this array, which is going to be n log n best case, right? And plus we are like iterating over these, and this is not going to be the most efficient way to do that. What we can do, we can use heap properties. What is heap property? Heap is the data structure that will return the minimum elements in the list. This is the basic one. It can return maximum too, but we are going to use the minimum one here. So what I'm going to do, I'm going to like heapify this nums list. After heapifying that, what will happen at index 0, we have the smallest element, right? So this is going to be 5, 8, 4. When we heapify it, it's not going to be sorted. The only thing is at index 0, we have the smallest element. So how can I get the third largest element? That's what I'm looking for, right? So what I'm going to do, if I make the length of this heap equal to k, the next element is going to be popped from the heap, is going to be k's largest element, which is the third largest element. So let's heapify this, which we did it, and then let's make sure the length of heap is equal to k. How can I do that? I need to pop elements from heap until the length of heap is equal to k. Now length of heap is equal to k, and after being heapified, as you see, the smallest element is going to be the third largest element. So now the third largest element is 4. Now let's add another a number to it. We are going to add 3. After adding 3 is going to be here, right? And the length of heap is not equal to k, so we are going to pop from it. And again, the length of heap is equal to k, and the third largest element is 4. Let's add another number. We add 5. After adding 5 here, so the smallest element is 4, so the length is not equal to 3, so we need to pop this. So what is the smallest element here? 5, which is the third largest element. now that we know how it works, we are going to build the init function and add function. For the init function, what we are going to do, I'm going to use heap Q because it's very convenient to use that. So I'm going to self k.k because it's an init function, self.noms is equal to noms, and then I'm going to heapify noms. So I'm going to say heap Q.heapify, right? So we get the minimum element at the beginning of the array, so noms, and then I'm going to say while length of heap, length of noms is bigger than k, we need to pop from it. Heap Q dot heapify, heap Q dot heap pop from self dot noms, right? So I'm going to pop from this. I forgot to add self here. I'm going to pop from this and self dot noms here. Until we have length of noms equal to length of equal to k. That's what we are looking for. So now that we have done this, we are done with the init function. So we have initiated the heap list, and we are done with this section. Now we want to see how we can add elements to it. So for doing that, I'm going to say heap Q dot heap push, right? We are going to add the value to this, the value that is given to us, which is an integer, and we need to say self.noms, add it to self.noms, and we add the value, and then we need to check if the length of this self.noms is bigger than self.k, and if it is bigger than self.k, I forgot self here. If it is bigger than self.k, I need to pop from it. So we are going to say heap Q dot heap dot pop dot heap pop and self dot noms, and we pop from it until we are having like k elements in it. And then what we are going to return, we return the first element, which is going to be the smallest element in the length of k, right? So heap index 0. There we go. So let me remove this and let's run the code and see how it works. So it's not heap, it should be noms, typo. There we go.